Hi, and welcome back to the Azure Database for MySQL monthly webinar series. I'm Shreya Raital, Product Manager in Azure Database for MySQL team, and hosting the series with me is Avnish Rastogi, who is also from the same team. We kicked this series off last month to bring you the latest updates on the service and to open up a new channel of interaction with all of you. In that first episode, we introduced MySQL Flexible Server, and we also demoed the 6 new features that went out in the last quarter. But in case any of you missed it, don't worry about it. Do check out our recording on our YouTube channel. Our handle it is Azure at Azure DB MySQL. So for today's session, we have another exciting set of topics planned. But first things first, let's try to keep this session as interactive as possible. So go ahead and drop a hi or a hello in the chat window and tell us a little bit about yourself. For example, where are you all joining us from, and what are you all looking forward to in today's session? For example, I'm from India. It's 9 p.m. at the night for me. I'm looking forward to the demos of recently announced features. So what about you folks? I see Deepthi has joined in. Hi, Deepthi. She's joined in from Seattle. I know it's really early in the morning for you, Deepthi. Thank you for joining in. And while you all do that, one other thing that I also want to call out is if you have any questions or feedback at any point during the session, go ahead and post them in the chat window and we'll address them as we go through the session. And just like last time, we have our product expert and feature lead, Sudesh Narayan Swami, on the chat window, who will be moderating the chat and addressing your queries. So thank you again, Sudesh, for agreeing to do that. So anybody else? I see a lot of people. Hi, Ahmed. Ahmed is from Ireland. I think that's the perfect time there at 3:30 p.m. Hi, Katya from Israel. Hi, Sanjay, again from India. Hi, Miguel. Keep it coming, folks, and let us know what you're looking forward in this session today, because we've got a couple of topics planned. The first 20 to 25 minutes, we are going to do a deep dive on how to migrate to Azure Database for MySQL. And we'll do a couple of demos, and we'll also invite a guest speaker on. Then we're going to cover 2 feature updates that went out last month, one of which will be demoed by the lead developer himself. And finally, we'll close out with a sneak peek of upcoming features. Meanwhile, I see Sudesh. Yeah, hi Sudesh and hi Miguel. So for the first section, the migration section, Avnish and I are going to do a little piece of play acting. We're going to test out our play, acting skills here. I'm going to play the role of a customer advocate whose customers are looking to move to Azure MySQL, and Avnish is going to play himself, the MySQL expert that he is. So, hi Avnish, thanks for meeting me. A couple of my customers attended the webinar last month and they learned a lot about Azure DB for MySQL. They were super impressed by how cost effective it is, how performant it is, and how easy it is to onboard to it, how effortless it is to use, right? So now they've got their current MySQL workloads in different environments. Some of them have it on premises, a few of them have a mix and match on premises, VMs, and on other clouds like AWS, GCP, etc. The obvious question that they all have in mind at this point, and they've come to me for, is how do we get started with migration? How do we migrate to Azure DB for MySQL? And most importantly, how seamless is that experience going to be, right? So that's where I needed your help, Avnish.
Yeah, no, thank you, Sharia. Really excited to be here. So, migration of MySQL instances to Azure MySQL is very easy because we run community edition of MySQL in Azure MySQL platform. Migration experience is lift and shift. So, regardless of whether your MySQL is running on AWS, GCP, or other computing cloud, on-premise, or even Azure VM, it's a lift and shift experience. And if you have MySQL single server instances, you can also migrate those to flexible server. So in coming next few minutes, we will talk about different migration tools customer can leverage. But before you do the migration of your MySQL instances, there are few things you need to plan. And first thing is the sizing. What's the size you would need in Azure MySQL flexible server to do the migration? So as we discussed in the last session, that in Azure MySQL Flexible Server, we have 3 service tiers: burstable, general purpose, and business critical. And in all the 3 service tiers, the storage we support is up to 16 terabyte, but compute varies from service tier to service tier. So as you can see in the burstable, we support up to 20 vCores. In general purpose, we support up to 64 vCores, and in business critical 96 vCores. We plan to support up to 104 vCores coming soon. Now, the nice thing about Azure MySQL Flexible Server is that you can scale up, scale down within the service tier or across service tiers. So, for example, if you start with one vCore in bus table and later on you need more compute, you can scale within bus table service tier, or you can scale across general purpose or business critical. And for any region, if you need to scale down, you can do the same thing as well. The next thing, once you decide the compute and the service tier you need for your migration, the next thing is the IOPS. So until recently, managing the IOPS was a manual process. You have to scale up, scale down your IOPS based on the application requirement. But we recently announced the public preview of the auto scale IOPS. It's an opt-in feature, but you can use this feature to auto scale IOPS based on your application requirements. And the pricing for auto scale IOPS is per million request basis. So it really eliminates the administration of IOPS, and you can leverage a platform feature to manage the IOPS based on your application performance requirements. The second thing is the networking and security. So in Azure MySQL Flexible Server, we have multiple options which customer can leverage to make sure your database instance is secure. First thing is the authentication and access management. We support integration with Azure Active Directory, so you can use this feature to manage your database users as well as groups. We also support MySQL native plugins like password authentication for password policy management, as well as caching SHA2 password plugin. Now in Azure MySQL Flexible Server, all your data is encrypted by default. We also support SSL and TSL enforcement, which is by default. And if for any region you need to turn off SSL, it's a dynamic parameter which you can use to turn off SSL if you need to do the disablement of that feature. Finally, on the data protection, if you want to bring your own custom keys, we support that feature as well. It's G8 now, so you can bring your own keys to encrypt your data, and all your keys would be stored in Azure Key Vault. And on the networking and network security, we have public access, which you can use to manage your database access using firewall rules. And finally, on the networking side, you can also do the network isolation using VNet injection. And if your application and database instances are deployed in the same VNet, you don't need additional configuration. But if for any region they are in different VNets, it will require VNet peering. And we also announced the private preview of the private endpoint or private link, and we plan to GA the feature pretty soon. Last thing on this, before you do the migration, is planning on the business continuity, high availability / disaster recovery. So on the backup and restore, we have auto backups, which you can retain from 1 to 35 days. And the backup redundancy depends on the provisioning of your MySQL instance. If it's a non-HA configuration, we maintain 3 copies of your backups in the same zone where your instance is deployed. If it's a HA configuration, we will maintain another 3 copies in another zone where your standby instance is deployed. And finally, if you enable the geo backups, we will copy those backups in the paired region, which you can use in case of disaster recovery. In addition to that, we also announced auto on-demand backups, which you can use to, in case you need to do any patching or upgrade, you can use these backups to roll back for any region. And on the high availability side, we have same zone high availability as well as zone redundant high availability. Same zone HA you can enable anytime, but zone redundant high availability you have to configure at the time of provisioning. But in both the cases, you can enable, disable HA anytime. The service level agreement really depends on the provisioning status. If it's a non-HA configuration, then we support up to 99.9% uptime SLA, 99.95% with same zone HA, and 99.99% or 4 nines with zone redundant high availability. Now, replication is another nice feature we have in Azure MySQL Flexible Server, which you can use for two use cases. One is to scale out your read-only workload, and we support up to 10 read replicas, which you can provision in the same region where you have the primary instance, as well as in different regions, whether it's a paired region or other regions. And at the time of provisioning read replicas, you can also specify the zone where you want to deploy your read replicas. We also have the data out replication, which you can use to replicate your MySQL instance from Azure to on-premise or other competing cloud providers like AWS, GCP, or Oracle Cloud. And there are two use cases we have seen for this data out replication. One is for analytics or reporting. If you want to keep your on-premise instances in sync with your Azure MySQL instance, or for the disaster recovery use cases. And finally, after the migration, you want to make sure that you have proper monitoring and alerting in place to make sure your database instance is up and running. We have several metrics which we are exposing to monitor your database instance. For example, compute, storage, InnoDB stats, as well as some other metrics on the networking and connections side. We also have logs which you can use to monitor slow query logs, as well as database activities using audit logs. And finally, we have workbooks, which is a dashboard you can use to monitor your database instance, and resource health and other activities which you can use.
Thanks so much, Avnish, for this detailed information on how to approach migration, right? And the next big question in all our minds is there are so many tools out there for doing the actual migration. So, how do we decide on which tool to use, and what is the recommended tools that you would suggest that we should use for each of our migration scenarios?
Very good question, Sharia. And like I said, before we have this MySQL Community Edition, we customer can use variety of tools. What we recommend, our recommendation is based on the size of the database instance. So if your database instance is less than 1 TB, we recommend Azure Database Migration Service, which is a first-party service. And you can use Azure Database Migration Service both for online migration as well as for offline migration. And if your database instance is over 1 TB, then our recommendation is to leverage MySQL, MyDumper, MyLoader, which you can deploy on Azure VM. And you can scale the migration based on the number of cores you have running on your vCore, on your VM. So for example, if you have a 32 vCore, you can have 32 parallel threads, which you can use to scale up the backup as well as restore from on-premise to Azure. And my peer Svikirti Jain is going to cover the DMS in few minutes. But they have Azure Database Migration Service and MyDumper, MyLoader are the primary tools which we recommend customer for the migration. And if you're using MyDumper, MyLoader, then you can use Data-In Replication later on to keep your MySQL instance in sync until you initiate the cutover. And we're going to cover the demo of Data-In Replication in few minutes.
Awesome. I do have a question from Katya at this point. What is the best solution to migrate Azure Database for MySQL from one subscription to another within the same tenant? Can you help with that as well, Avnish? So same tenant moving across subscriptions with minimum downtime.
Yeah, so for that, either DMS as well as MyDumper, MyLoader should be fine. Again, you have to you can decide between these tools based on the size of your database instance. But either of those tools should be fine to move from one subscription to another subscription.
Awesome. Yep. I think there's another question from Lior. He says MyLoader versus ADF. What are your thoughts there, Avnish? Like, do we use MyLoader versus when do we use ADF? Azure Data
If you are
Factory.
simply migrating your MySQL instance, I would suggest to use MyDumper, MyLoader. But if you're trying to move selected data, let's say you have 10 tables and you're trying to move only one or two tables, then Azure Data Factory might make sense. But you can use MyDumper, MyLoader as well, or even DMS, because in either of those tools, we have the granularity to select the tables or individual databases you want to migrate.
Yep.
In
Awesome.
fact,
Thanks.
DMS would be a very good experience because you can select the databases or tables you want to migrate, and Swikriti is going to cover some of those things in the demo.
Yeah. I think Ahmed also had another question related to what's the recommended approach to move from flexible server to flexible server in different regions online with minimum downtime. So I think again, Azure DMS, I'm assuming, would be like that one-click experience that we can provide. So stay tuned, Ahmed.
Yeah.
We'll show two of those methods that we can use to do this. Yep. Back to you, Avnish.
Yeah. So another thing we want to briefly cover is the migration from single server to flexible server. Again, we have these tools, Azure Database Migration Service or MyDumper, MyLoader plus Data-In Replication, which you can use to migrate your single server instances to flexible server. We are also planning to announce another migration tool for single server to flexible server, which we will discuss in the upcoming sessions. And we also have some custom scripts which are available on the GitHub, which you can leverage to do the migration from the different locations to Azure MySQL. So with that, I will invite Swikriti Jain, who will cover the database migration service and the demo of that experience. Swikriti?
Hi, thanks Avnish for having me here. Hi everyone, I'm Sweekriti. I'm part of the Azure Database Migration team. So Azure Database Migration Service, it's a fully managed Azure service that helps you easily migrate your various databases to their corresponding Azure data services. It offers reliable migration solutions with minimal downtime. Now for Azure Database MySQL, we have various features and capabilities. First is MySQL schema migration. This enables users to migrate the schema objects such as tables, views, triggers, events, functions to the target database. It is useful to automate some of the work that you have to do before starting the migration. Then we have offline migration with consistent backup. This allows users to take a consistent backup of their MySQL server without losing data integrity at source because of the ongoing CRUD operations. So you can take a consistent backup at point in time from your source to target server. Then we also have the MySQL online migration with minimal downtime. It does an initial load, which is the consistent backup. And then from that position, it streams your bin log changes from source to target database. Azure DMS uses streaming for your bin log changes. So it's actually easy to set up and you do not need a physical connection between your source and target. We also added a recent capability to migrate your users and logins so that you can migrate your privileges and various user logins. So moving on to the demo, I'll be doing a demo for an online migration. In the interest of time, I've already created a service. And this is the service. And I've also created a migration project here, MySQL single to Flex. This is a project to migrate from single server to Flex. DMS offers online migration, offline migration, as well as replicate changes. For this demo, let's go ahead and do an online migration. The first step is to connect to your source server. This is pre-populated with my previous migration that I did. So I just enter the password details. Here it's making sure that you can connect to the server, collecting some information and also doing some validation. The next step will be connecting to your target server. And it has pre-populated the details from my previous migration. And there also it's doing some validation. As you can see, we have these preview features to migrate your accounts and privileges and also your schema. So for this demo, let's select all of them. Currently, you do need to have an empty database and target server to do the migration, which will be coming up where you can migrate your whole server. So I have this database Data-In, which is already created on target. It's just empty. And we selected that. Now it collected all the tables that are there. I'll be doing all these tables, and also we'll be migrating the schema so that your tables are created on the target server. Next step is the advanced migration settings. By default, we have tuned the migration so that it works for most of the migration, but there are cases where you'll need to tweak some settings for it to be more performant. So you can do that on that step. Next is the summary. So these are your source and target details. Let's name it single to flex migration and start it. So as you can see here, this is the screen. It's waiting for data movement to start. This is the initial load. These are the 4 tables that we have. So currently in the background, it's taking a lock and getting the bin lock position, and then starting migration and doing the initial load. So yeah, it's pending right now. Okay, as you can see, it has completed these 4 tables, and these 2 are for your privileges. So we migrate your DB and system privileges to your target server. Once it's done with initial load, it does the CDC part, which is the replicate changes. You can see there are 0 incoming changes right now. And there's also a bin log position that we report, which is up to which bin log position we have migrated the changes. I did an insertion right now in the background to insert 5 rows in one of the tables, and you can see it inserted those 5 rows, and also to tell you the bin log file position. Once you're sure that your target is caught up to source and there'll be minimal downtime, you can do the cutover. So you can check this by running show master status on your target and see what's the bin log position corresponding to your source, and you can start a cutover. This will stop the replication, and up to that bin log position, your target will be in sync with your source. So yeah, as you can see, the migration is completed now. Thank you.
Yeah, no, thank you, Svikriti. So with that, we also want to show you how to do the data and application post initial seeding using MyDumper MyLoader. So in this demo, you will require to have a replication user to set up the replication post initial seeding. So because replication user would be used for the replication, it will require replication slave permissions. So you can use this create user and grant permissions to create the user. And there are several stored procedures which we are exposing to configure the replication as well as maintain the replication after the creation. There are 2 procedures. One is to start and stop. And later on, if you need to remove the replication, you can remove this remove master command. And all these procedures are documented in this public facing documentation, which you can reference later on. So for this demo, we are assuming that initial seeding had been taken place using MyDumper MyLoader, and you have the bin log position from the MyDumper MyLoader. But in this case, I will use show master to get the bin log file, bin log file and bin log position, and then set up the replication. So what we have here, that we have this flexible server instance, which is my target instance. And this is my single server source instance, which I will use to to replicate or migrate to flexible server. And I'm using this Azure VM to configure the replication between single server and flexible server. So I will connect to my VM. And once I connect it to the VM, this is my single server. And as you will see that it doesn't have any databases right now. So it's a empty MySQL instance, and I have this bin log file and bin log position, which I will use to configure the replication. So same thing on the flexible server side. It's a empty instance, and this is the command or the procedure which I will use to set up the replication. So you specify the source instance, and then you specify the username and the password, and bin log file and bin log position. So bin log position in this case is 1899. So I'm updating the bin log position, and that's pretty much it to set up the replication. Once you have the change master in place, then you start the replication, and you can use this command show slave status to make sure that everything has been configured properly. So now I will make some changes on the source instance single server. So I will create one database and a table in that. So here I'm creating a table now. So basically I created one database and a table. And now if you look into the flexible server, so you can see that both table and database has been replicated successfully. So it's very easy to configure the Data-In Replication using these procedures we are exposing. And what I demoed in this is to configure the replication using binlog. But for any regions, if you need to do GTID based replication, we plan to support that as well. So that's what I planned, Sharia, to quickly walk through how to configure the Data-In Replication, which customers can use to keep the target instance in sync when they do the migration using my dumper my loader.
Awesome. Thank you so much, Avnish and Swikriti, for the detailed, approach of how to migrate as well as the demos. This is super helpful. I think at this point we don't have any additional questions. There was a question from Katya asking, are there any additional impacts or changes that will happen while migrating from single server to flexible server? Should we look at anything, any changes that we need to do before we migrate from single server to flexible server?
Only thing I would suggest is, that's something I mentioned in the beginning of the session, is that the sizing is extremely important. And if you're doing the migration of large MySQL instance, let's say 1 TB, a couple of terabyte, I would suggest to make sure that you scale your target instance to maximum compute and IOPS, so that's not the bottleneck. And you can scale down to based on your application requirement post migration. But that's the only thing I would suggest. On the source system, there should not be any impact because we are just reading the data from the source. But it's a target which you need to make sure that configured properly.
Awesome. Thank you so much, Avnish. I don't see any other questions, so we'll move on to the next section. That is the latest feature update. So we released two major features over the last month, folks. The first one being data out replication. So with this replication capability, you can now synchronize the data from Azure Database for MySQL Flexible Server as the source to any other MySQL server, which could be hosted anywhere. It could be on premises, on a VM, on Azure VM itself, if required, or on other clouds. So the flexible server is the primary source, and you can configure any other server to be a replica. So what this implies is three things, right? One is you can augment your hybrid cloud strategy. For example, you can have a seamless integration from your primary flexible server onto your on-premises databases. And like Avnish said, you can use the on-premises systems for use cases like reporting, or just in general hybrid cloud strategy itself. Second one is a multi-cloud strategy. Now, to sync data between your flexible server, primary, and any other MySQL workloads on other clouds. Could be AWS, it could be GCP, anywhere. Right. And finally, of course, it's migration. So you can perform near zero downtime migrations, just like the migrations that we were seeing so far, online migrations from flexible server to literally any other server. So this is essentially avoiding any kind of vendor lock-in with us whatsoever, right? So that was the first feature that went out last month. And the second one is we released a MySQL connector for Logic Apps and Power Automate. The Power Apps feature connector is also coming soon in the next month. But to learn more about this feature, I'd like to invite one of the lead developers who worked with the connector, worked on the connector, Aditya. So hi, Aditya, welcome, and thank you for joining us today.
Hi Shreya, thanks for the invitation. Hello everyone. I'm part of the Azure MySQL team, so I work behind the connector.
Can you
Yeah,
tell us a
and
little bit more about the connector, especially like a few usage scenarios for the connector before? Yeah.
sure. To give a background on the connector, the Power Platform already had a MySQL connector that can work with on-prem databases. Now we had customer ask coming in for cloud Azure Flexible Server, a connector that can work with that. So we introduced this connector. Now with this connector, users will be able to create CRUD operations on the connector. They can automate flows, and they can also integrate with all the other connectors present in the Power Platform.
Awesome. You'd love to see the demo. I think it's already here. So, uh,
Sure.
yeah.
So I will walk you through a data ingestion flow using the connector. So in this demo, I have already created a MySQL flexible server here. And I have a database called IoT store. So now consider this as a typical IoT application wherein you have data coming in from different sensors. So I have a couple of mock sensors here, namely sensor 1 and 2. So from time to time, consider these producing temperature data that you want to process to MySQL. So here you can see the device events table, which I have designed for this purpose. So currently the table doesn't have any data. Now what we'll do is we'll create a Power Automate flow that can ingest data into this device events using the connector. So here device events captures nothing but an event ID, device ID, and then temperature data. Now, yeah, again, as I said, it doesn't have any data now. So we'll be moving on to Power Automate, where I'll be explaining the flow behind inserting data into this. Now, here I have used existing operations as well as the new connector operations here. I'm using a HTTP request as a start point for the flow, and I'm using the insert row and the get row operations, which we introduced recently with this connector. And we also produce a response here. Now, since the trigger is a API endpoint, the user can actually send in some data by just hitting an API. Now, for this setup, I have created a response body schema that accepts the data. Now, when you closely examine this schema, we have the exact same format as far as like the device events table, wherein we want to insert the data. Yeah, it's just exactly the same. Now, once data arrives into the API, it flows on to the next step, which is the insert row operation. Now, I am using the existing connection that I created for insert row. But if you want to create a new connection, you can just hover the menu over here, and then you can add in a connection. So for connection creation part, you need the DNS name or the host name of the MySQL server. And you specify your database name details and then the user ID and password credentials. Now you can see that we have an encrypt connection option. This is an optional SSL option. You can enable it based on your requirement. So once you click on create, the new connection will be created. Yeah, it got created. Now let's closely examine the parameters for this insert row operation. So the server name, database name, and table name, all of these parameters you can retrieve from the connection settings, or it will fetch you automatically based on your table schema. And I have the other columns, which is the device ID and event ID. So here, what I have did is I have populated these dynamically from the API parameters. Yeah. So we plug in these dynamic parameters into the connector. And post inserting this row, I wanted to actually fetch the row that got inserted and then use it as part of the response body. So here I'm using the get row operation that we introduced. So notice that the parameters are mostly the same, except that it accepts a row ID. So row ID is nothing but a unique ID, which is used for fetching the row. So in the background, it would run a select query and then basically get you the row that you want to insert from the database. So here I am plugging in the event ID that I received as part of the API data. Now, as a final step in the response, I am plugging in the body that I received from the get row operation, and then I am sending a JSON response to the client. Now, you can go ahead and save this flow. So upon saving, Power Automate creates you the API endpoint from which you can actually trigger the flow. So if you see here, we have the API endpoint URL here. Now I'm going to copy this URL and then move it to Postman. So this is a post API, and then I'm going to insert some sample data into the connector. So I have created sample data here. A couple of inserts I'll be doing. Yeah, and then the JSON, it accepts a JSON request body. So when I click on send, you can see that the connector responds you with a 200 response code. And then the details of the body of the get row operation gets converted into the response. Now I'll also insert the other row. Now once we insert both the rows, I'll show you on the database side how it looks and how it functions. So we got a success on the other insert as well. So previously there was no data in the database. Now after the API calls, you can see that the data got inserted via the connector. So that's how with a few clicks and you can populate the operations in the logical way, and you can automate any flows for your application.
Awesome. Thank you so much, Aditya. And with this connector, you can, so folks like you, with this connector, we can automate any kinds of business processes and workflows with minimal efforts. And you can also encourage your citizen developers from your organizations who may want to work with MySQL to easily do so. Right. So thank you again, Aditya.
Yeah, thanks, Shreya.
So on to the final section then, upcoming feature updates. I think we did cover a couple of these last time as well, but these are the features that are coming up in the next 2 months. So Power Apps Connector, just like the one that we had for one that we have for Logic Apps and Power Automate. Second, on top of our existing Data-In Replication capabilities, we'll be adding support to enable Data-In Replication for HA-enabled servers as well, both same zone as well as zone redundant HA servers. And third one of the most awaited features, support for provisioning read replicas in paired regions. What this means is that you can not only can you scale your read workloads in other regions, but you can also augment your DR strategy, especially in case of regional failures. So if there is a region failure in the region that your primary is at, you can promote your replica in the paired region as your primary and go ahead with your business, right? And finally, private link, another feature that many have been waiting for. So on top of the current connectivity methods that we have, that is public access and private access VNet integration, you can also connect from your apps using private link. So that's all we had for today, team. To learn more, you can navigate to aka.ms MySQL resources. Avnish, do you want to change? Can you share that? Yeah. Now you can navigate to MySQL resources, which is our one-stop shop for all the resources. You can check out our documentation, our blog site, and if you have any questions, you can feel free to reach us at Ask Azure DB for MySQL at service.microsoft.com. Stay tuned for more updates and announcements by following us on social media and subscribing to our YouTube channel. Our handle on YouTube and Twitter is at Azure DB MySQL. So yeah, go ahead and subscribe to our channels, and that's about it. Thank you all for tuning in. We hope you enjoyed this episode. We would love to hear your feedback on the session. So here's a link to the feedback form, and most importantly, if you have any requests or suggestions for topics that we should be covering in the upcoming sessions, or if you want to appear on the show with us, please do fill out the form and let us know. So see you all in our next session then, next month, 8th February at 7:30 a.m. Pacific time. Thank you all.
Thank you, everyone.